Hello everyone, welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and I am going to be walking you through one of the most important aspects of becoming a strong math student. And by the title of the video, you can see that in this video, we're going to be talking about transposition. How to effectively rearrange an equation or a specific formula. Now in this part one, I'm going to be walking you through a series of fundamental questions. Very basic questions, but questions that progressively will improve your transposition ability. Now with the ability for you to transpose or rearrange an equation to create a new subject or an intended subject, a required subject, it's going to be a strong tool that will help you to be really advanced or to be really comfortable with more advanced topics. Now I find that over the years that I've been teaching, this is not something that I see a lot. It's always the assumption for many students that they should know how to transpose. So I'm going to be walking each and you guys here today through a process of understanding how to be effective when it comes to transposing any and every equation. This is in fact part one. In part two, we're going to be doing some advanced questions involving roots, powers, and factorization. So of course, if this is the first time here on the channel, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and do not forget to share this out to your math communities. I do hope that at the end of this video, you'll be able to, in fact, achieve what you came on this channel to achieve. Alright, so let's jump right into the lesson. Now, I do have some information here on screen for you, and I'm walking through a couple of definitions, a little bit of explanation. So for the next 15 minutes, we're going to be talking about the fundamental aspect of transposition. So firstly here, we need to have an understanding of a formula versus an equation. And it says here, the apex definition is, a formula is an equation that is specifically used to find the value of a specific unknown variable. Now, when we talk about formula, guys, we're talking about renowned axioms, formulas that are equations that are basically used to find something in real life. For example, let's say that I wanted to find the area of a garden that is circular and has a radius of a certain amount of units. I could use the area formula here, a very renowned formula, A equal pi r squared. Now, it could be a case where maybe you want to calculate the period of a pendulum. So let's say that you wanted to find the time it takes for a pendulum to swing from the left side to the right side. So therefore we could use the formula period equal the square root of the length divided by the gravitational force or the gravitational constant. Let's say that I wanted to calculate, let's say, the speed at which an object is traveling, or the speed of a car. Then I could use the formula S equals distance divided by time. Or maybe I wanted to calculate the final or the initial velocity of an object given its acceleration or its time. Then we could use the formula v equal u plus at. These are just a few of the most renowned formulas used in mathematics and in physics. So these are in fact renowned formulas, and of course, as we said here, a formula is an equation. It also begs to understand that you should note that not every equation becomes or is a formula, but every formula is in fact an equation. So why is it that all equations are not formulas? I can come up with various types of combinations with letters, just random letters that do not mean anything, to which you're going to be seeing throughout this video. The ones I've listed here are just the formulas that are well renowned, but throughout this video you're going to see an arrangement of various letters that has no significance in finding anything specific. Now we're going to be looking now here at the basic rules of transposition, and in my last couple of uploads I went through part 1, 2 and 3 of solving equations. So solving equations is very similar to that of transposing an equation or transposing a formula. It's more or less the same, but with solving an equation we're actually getting a value for the unknown variable. When it comes to transposition, we're just rearranging how the actual equation looks based on the variable value that we're looking for. So the rules of solving an equation is the same rules for transposing an equation or transposing a formula, except that at the end our answers are most likely going to be an expression as opposed to being a specific value. So we've seen this before in part 1, 2 and 3 of solving linear equations using various methods. A link will be pinned in the description box below, so do check out those 3 tutorials. Number 1 is that we should ensure that the subject is always isolated, and it is best that we keep the subject positive at all times, but there are going to be situations where your subject will automatically end up being negative, which then means that you're going to have to divide both sides of the equation by the negative coefficient. Rule 2 here is that try to keep the equation balanced. Not try, but the equation must be kept balanced by performing the same operation done on one side. You have to also do it on the other side. So if it so happens that I have to say here, divide an equation by here, say, let's say I have, let's grab my pen here. So let's say I have an equation like, say, x plus 4 equals 5. What this means then is that for me to isolate x, if I decide to subtract 4 from the left side of this equation, then I will also have to subtract 4 from the right side of the equation. And so by subtracting 4 from the left, I end up cancelling the 4, but the equation is kept balanced because I also subtract 4 from the right. So therefore I end up with an answer here that x is equal to, say here, 1. Or it could be a case where maybe I am actually multiplying. So it could be a case where maybe I have something like 2x equals 3. Then of course, because I want to keep my equation balanced, I will then have to say 2x divided by 2, but it also means that I have to divide on the other side as well by 2. That's what we call splitting the product. So 2 cancel 2, therefore x is equal to 3 over 2. And I've chosen to use an equation because I want to connect my most recent uploads with this video, because we are doing the exact same thing that we did in those videos. We are doing it now, but the exception is that we are mainly going to be getting an expression expression for our answer as opposed to an actual value. Let's say x equals 3 previously, you're going to get something more like, say, x equal 2v minus r over t. So that's what we're going to be getting now. So hopefully that is, the expectations are set. And 3 here says that any term that you happen to have to bring across the equal sign, or even it could be an inequality sign, it begs to always remember that the sign must be changed to its opposite sign. So this is just like part 3, or rule number 3 here is very similar to that of rule number 2. It's just that there are certain situations, certain instructors that will teach you one way and other instructors will teach you another way. So for example, some instructors will tell you that x minus 4 is equal to 10 should be solved like this: x minus 4 plus 4 equal 10 plus 4. So that negative 4 cancels 4, x is equal to 14. So that's instructor number 1. But also instructor number 2 might say that this very same equation here can be solved simply by bringing the 4 over to the other side. So therefore x is equal to 10. Because I carried negative 4 over, it becomes positive 4. Therefore x is equal to 14. So every instructor that you encounter will have a different way of solving the equation, but they are more or less the same. So that's how I tied rule 2 here with rule 3. So since we have already watched those tutorials, we are already familiar with the basic rules. You carried over a negative sign, it becomes a positive. You bring over a positive sign, it becomes a negative. If you divide both sides by, if you have to split the product, you're going to have to divide both sides by what you don't want. And if you have to rejoin if you have to isolate the variable by removing the denominator, then we're going to be multiplying both sides of the equation by the denominator. So all those rules we are already accustomed to. Let's dive right on into some very basic examples here of what we're going to be getting. So the instructions are going to be that you should make something the subject of the formula, or express a particular variable in terms of 2 or 3 other variables, or it could just simply be an instruction that says for u or for v or for r. So there are a couple of different ways that they'll ask you, so you'll know that the particular question that you're attacking, or the particular question that you're trying to resolve, is in fact a transposition question. Many students at certain level struggle with understanding the English of math. So therefore then, I'm going to be walking through a couple of those ways how the questions are asked. So for this one here, it says v is equal to u plus t. And we're being asked to, basically we're being asked to make u the subject. So this is very simple here, because there's only one variable that is connected to my subject u, my intended subject u. So since that t is connected to my subject, I'm simply going to transpose the t to this side here, and I'm going to end up with, say here, v take away t is equal to u. So right here you can see that u is now by itself on one side. Therefore my answer is, as you see here on screen, v take away t equals u. Again, another instructor, as I said, may say to you, hey, this particular equation can be worked v take away t on the left, and that's going to be equal to u plus t take away t. So this instructor is using rule number 3. I am particularly using rule number 2 And that's the rule that I'm going to be using right throughout this video. I'm going to be using this carryover method. But it's very important that I also show you that it can be done this way as well. So then you realize here that V take away T is equal to U. And if you notice clearly here that T cancels T. Therefore, the answer is exactly the same. So I'm a Caribbean math teacher, so I'm taught to do this carryover. But when you go on other YouTube channels, you might find other American instructors using this sort of technique here, subtracting from both sides or adding to both sides. Now, going forward, as I said, I'm going to be using rule number 2 here. So, next question here is that x is equal to v take away u. So what this means for me then is that I'm going to go ahead and make v my subject simply by transposing negative u to the left side. So this then leaves me with x plus u equals v. And so because my subject is now, this intended subject is now by itself on one side, then that becomes my final answer. Now, if we go on here down to question number 3, we're going to be looking at making R the subject. And here is where you have options in terms of your personal preference. So, to make R the subject, we can therefore go ahead then and do what you do at first instinct. You'd transpose the D. Bear in mind that pi therefore take away D. Why take away D? Because the sign in front of the D, well, in fact, there is no sign in front of the D, therefore it is an assumed positive D. So by bringing that over, it becomes negative D. Some students might interpret that once the D goes over, then the minus goes with the D. This minus sign here is not attached to the D, it is in fact attached to the R. So this minus sign is attached to the R because whatever sign appears before, this is before, this is after. This is before, this is after. So whatever sign appears before a variable or a constant belongs to the variable or the constant. So this minus sign is attached to the R. So that means the D that I brought over was in fact positive D that now becomes negative D, which therefore then leaves my subject negative. Now if you go back to rule number 1 here where we stated that ensure that your subject is always isolated, which we have done successfully on 2 occasions, and try to keep it positive. I did mention to you that occasionally you might find that your subject automatically, based on your transposition, your direction of transposition, will automatically be left negative. So how do we handle a situation then where our subject is negative? We're going to therefore divide both sides by -1. Whenever your subject is negative like this. So we therefore go ahead and say pi take away D divided by -1, and we have to balance the other side of the equation by dividing also by -1. So by dividing both sides by -1, we end up with -1, cancelling the -1 here. Remember that the coefficient of a variable without an indicated number is in fact 1. So the negative will cancel the negative. Therefore, we end up with R being equal to. Now, let's pause here for a moment. You're going to find many times when you watch advanced tutorial videos on algebra, you're going to find that the instructor will divide both sides by -1 and then ending up turning around the letter that is at the back comes at the front and the letter that is at the front comes at the back. And why do they do this? I struggle to understand why an instructor does this. Why isn't it not, say, minus pi, minus dr? You know, I always struggle, and I wanted to let you guys know that why we do this is if we divide -d by -1, we end up with a positive D. And most times we kind of like when our positive variable is at the front. And so remember that this pi here is positive. Okay, this pi is positive. So when you divide a positive by a negative, you end up with a negative pi. So we like our negative values or terms to be at the back. And so that's why we end up with d minus pi as opposed to pi minus d. Now, of course, if you want, you could actually go ahead then and simply divide both sides by negative. We could say negative 1 open bracket pi minus d equals r. Or we could simply say, okay, divide pi by negative, we end up with negative pi, and divide negative d by negative 1, we end up with positive d. So whether you write the first one here, minus 1 bracket pi minus d, or you write minus pi plus d, or you write d minus pi, they are all the same answer. So I wanted to make sure that that is clear to all of you, that in the event that you see an instructor using what I would say is a very peculiar way of writing only answer, do not be spooked. It all boils down to personal preference. But I primarily always tend to just turn my variables around when I happen to having to divide both sides by a negative number. Now, this can easily be avoided because at this moment, most of you guys would probably not feel too comfortable with that method. You can easily then, as opposed to transposing what you do not want beside your subject, because your subject is negative, we can actually go ahead then and instead transpose the r to the left and bring pi to the right. So therefore then negative r gets transposed, become r, and notice that I didn't touch d remains, and pi that was positive becomes negative, and in one line you're done. The answer is r is equal to d take away pi. Of course, you guys are going to hit the like button right now because that was so very easy. It is easy to get the answer, but you have to remember that this technique, this method here, this very simple one-line method here, you must recognize when your subject is negative. And so you must remember that when your subject is negative, you're going to transpose the subject as opposed to transposing what is connected to your subject. Alright guys, go ahead and hit that like button for me, and do not forget to subscribe to the channel before we're going to be moving on to the next level of this equation. Now we're going to be looking at how to split a product when you're transposing. Remember that all these examples are fundamental and progressive examples that we are eventually going to use each of these tools and put them together so we can understand more advanced transposition questions. So here we're looking at splitting the product. And what do I mean by splitting the product is that when two variables, that is preferably the subject that you want and another variable or a constant, if they are joined together by a product, meaning by a multiplication sign, then we have to split the product by dividing both sides of the equation by the variable that you do not want or the constant that you don't want. In other words, we're going to divide both sides of the equation by what we do not want to be connected to our subject or our intended subject. Now in the first part of this video, you might have seen me do a quick little example of that, but let's look at it then. We end up here with 3w equals v, and we need to isolate w. That means we need to get rid of the constant 3. So therefore then we're going to go ahead and divide by what we do not want, which is 3. We don't need 3 to be connected to the w, so we divide by what we don't want. It's an equation, so it has to be kept balanced by doing the same operation on this side here. So therefore, easily then, you'll find here that the 3 cancels the 3. Therefore, w is now all by itself. And then w therefore is equal to v divided by 3. And that is your final result. Now, that example is when a constant is connected to your subject by multiplication. Let's look at an example where it's just a random variable that is connected to the subject. Here we have AB equals t. And so with AB equals t, we're looking to make A the subject. We need to isolate A, so we need to divide both sides here by what we do not want, which is B. So we end up with AB divided by B, and that's going to be equal to t divided by B. By doing so, you're going to see clearly here that A cancels A, pardon me, that's a mistake. That is, B cancels B, therefore we end up with A being equal to t divided by B. And so we've just rearranged the equation to make A the subject. So pretty simple so far, right? Leave your thoughts in the comments. We're looking at an example here now where not only that our subject is connected to a variable, but it's connected to more than one variable into in a product form. So here we have pi RT equals L plus W. Bear in mind that these are equations, they are not formulas. We don't use these to find anything specific in real life. It's just a bunch of random letters that I've put together here, connected by multiplication, division, addition, and subtraction. So here we have pi RT is equal to L plus W, and we need to make R the subject. So far we have always been just eliminating one unwanted variable. Now we can eliminate 2 variables at the same time. Now if you want to eliminate the pi, then you want to eliminate the t, it's just a longer process. And since both unwanted constants are connected to my intended subject by the same operation, why not just get rid of them at the same time? So we can go ahead then and say, if we want to find r, we need to eliminate pi and t. So you can go ahead and say, oops, let's get a different color ink here, guys. So let's go ahead then, and we're going to say pi RT divided by what we don't want, pi and t. And that's going to be equal to L plus W divided by pi t. So by doing that then, you will recognize here that pi cancels pi and t cancels t. Therefore, we end up with R is equal to L plus W all divided by pi t. Remember that we have already set the expectation that the answers that you're going to be getting are not going to be numerical values like when we were solving the equation. It's going to be algebraic expression. So our answer for that rearranged subject is L plus W divided by pi t. Now for this example here, we're looking for x, this time a constant and the variable is connected to my intended subject. So in this case here, I need to get rid of 2 and y. So we're going to go ahead then and we're going to say here 2xy divided by 2y is equal to a divided by 2y. And so just like before, 2 cancels 2, y cancels y. Therefore, we're left with x on the left being equal to a divided by 2y. Now, we won't be able to do this if, say for example, the 2 was connected to the x by addition and the y is connected by a product. That is two different rules. One is a carryover method and one is a balance both sides method. If they are both connected to the intended subject by the same sign or same rule, then we can eliminate both at the same time. Okay? Now, the next set of examples I'm going to show you exactly what I mean. Let's move to stage 3. And it's going to get a little bit more interesting here. Alright, and why I'm doing it like this, guys, is because a lot of students are struggling fundamentally. This video is a very compact video that will cover 10 different areas in math using one topic. So here we go. We're going to be removing the denominator. When our subject is connected to a denominator or our subject is in fact the denominator. Let's have a read. It says here that if the required subject is connected to the denominator, that is, if the required subject, what you're looking for, if it's connected to a denominator, we can multiply both sides of the equation by the denominator so that we can cancel. Let's do that part first. So here, I'm looking for x to be the subject and x is connected to a denominator t. So according to the part 1 of what we just read here, we are going to be multiplying both sides of the equation by that denominator. So we're going to end up with t multiplied by x over t, and that therefore is going to be equal to t multiplied by 4. And so therefore then, you'll notice there, just as how the instruction says, that we are going to cancel. So that will allow me therefore then to say t cancels t, therefore x is equal to t times 4, 4t, or t4, but preferably 4t. And since x is now all by itself on one side of the equation, therefore we can conclude that this is the final answer. Now, it also says here that we can actually cross multiply. What does it mean to cross multiply? It simply means then that if I have an example, let's say here t over 2 equal v, so t over 2 equal v, I could simply go ahead and put the v over 1 and we can go ahead and cross multiply. So since we're looking for y, I'm going to be starting with the direction. It says here for y, I'm so sorry, it should have actually been for t. Pardon me, guys. It says here for y, but it should actually say for t. So we can go ahead here and cross multiply. So by cross multiplying, we're going to say t multiplied by 1 is t, and 2 multiplied by v is 2v. Therefore, the intended subject, which is t, is on one side of the equation by itself. Therefore, that is my final result. So you can see, guys, that these are very simple questions, but it's when where the challenge really lies is when we start to put each of these little concepts together in one question. Then that's where most of my students struggle, or most students struggle. Now, let's go back. So we finished with the top section here. Let's have a look at the bottom section here. It says that if the subject, or if the required subject is the denominator, then we can still multiply both sides of the equation by the subject itself. Hence, that would cause the subject to move from the left-hand side to the right-hand side, or vice versa, the right-hand side to the left-hand side. Let's have a look at what that means. Here we're looking for R, and unusually you're seeing here where the actual intended subject here is the denominator itself. So what we can do here is that we can still multiply both sides by R. I find that many students, when I ask them this, they say they're going to multiply both sides by X. So the common mistake would have been to say, okay, I'm looking for R, so I need to get rid of X, and they'll do something like X multiplied by X over R, then they'll cancel the X, and that is horrific. That is actually quite mathematically incorrect, because X times X is X squared. So here, what I want most of my students here online to understand, that when you're multiplying both sides by a specific term, constant, or value, you're not actually getting rid of the term. You're just removing the term from one side to the other side. So here, even though I'm looking for R, I'm automatically still going to multiply both sides of the equation here by R. So what's going to happen is that I cancel the R from the left side of the equation, and it automatically lands up on the right side of the equation here. So we end up here with YR. But R is still not isolated, because now step one was to get rid of the R from being in the denominator, and now I still need to isolate R by dividing both sides by Y. So therefore then I'm going to go ahead and say X divided by Y is equal to YR divided by Y. So now finally then you'll see here that Y cancel Y, so therefore X over Y is equal to R. So R is now officially by itself on one side of the equation. Now, if this is the way you prefer, then by all means, do it until you master it. But when you reach to a higher level in math, you're going to need to be able to pick up on certain useful rules. Or you're going to have to get used to what is the usual outcome when you use this method. So here, let's go back to our information on screen. That covers this section here. Or it could do what is known as a swap position technique. When your subject, the intended subject, is in the denominator, you can actually use a very simple method here by swapping the denominator with the opposite numerator. So what that means then is that if I go to this example here and I look at V equals U plus T, again, you're looking for here, say, T. So in this case here, I could go ahead and multiply both sides by T using the method that I just used up here to find R. But I could easily say, okay, since my intended subject is in the denominator, I could swap the position of the V with the T. Therefore, we end up with T being at the top and T being at the bottom. And voila, that is your final answer. And you must be saying, oh, but sir, that method is way easier. It is easier, but it also comes down to, can you remember to use that method when your subject is at the bottom of the equation? That's where the outside practice comes from. All of these examples here are just examples that I'm showing you that you can utilize when you're in an advanced situation and you need to be efficient and effective. Now, there's also another way in which you can actually solve this question here. And you'll see here where I explained about the swap position. We could actually go ahead and get the answer for T here. Let's just rewrite this question. So we have V is equal to U plus T. Pardon me, not U plus T, U over T. What we could do here, and this we don't use it we use this technique mostly at an advanced level. We could go ahead here and multiply both sides of the equation by the reciprocal of T. So since T is over 1 normally, then what you could do here is that you could multiply by the reciprocal, which is 1 over T. And that would automatically cancel the T from that side of the equation. In other words, then we're looking at this, and this technique, as I said, is used mostly at an advanced level. You will find that most advanced teachers will say that this equation is actually V equals U multiplied by 1 over T. Because since T is the denominator and U is the numerator, U times 1 is still U. So it's the same equation. So then by going ahead here and multiplying by the reciprocal, that's going to be the reciprocal of 1 over T, which is T. We could go ahead here and we could say the reciprocal of this here is T. So we could say T multiplied by V is equal to U. Pardon me. We're going to divide. Okay, so we're going to go ahead and we're going to say V multiplied by T is equal to U times 1 over T multiplied by T. And so therefore then, by cancelling here, this T cancels this T. So we end up with Vt equals U. And since we're looking for T, we can go ahead then and divide both sides by V. And this is a longer method, but it's something that's worth knowing. So T divided by, pardon me, Vt divided by T, or divided by V, pardon me, is equal to U divided by V. So V cancel V, therefore T is equal to U over V. And I'm almost certain that you guys are not even going to even think about doing that, because that's just going into more in-depth detail. I would just simply recommend swapping the position or multiplying both sides by the subject. Alright then. So we're going to be looking now finally at multi-step transposition. We're going to be binding all of what we just learned moments ago: the addition, the subtraction, the multiplication, the division. And so this is where the challenge comes in for many students. Perhaps the first couple of questions are going to be easy, and then around to the end of this video you're going to see where the question gets a little bit more tricky. Now I'm going to be using my rule of thumb here. I follow a very basic rule of thumb, and this is my personal way of thinking. I'm not sure if this is a rule that exists out there, but this is something that I taught myself and I've been using for many years, that makes transposition of any equation very, very simple. So my rule of thumb is that the term, or it could be a constant, that is closest to the intended subject, the subject that I'm looking for, is going to be the last thing that I'm going to eliminate, that I'm going to be trying to get rid of or to remove or to isolate. It's going to be the last thing. And my rule of thumb is this. I follow the apex rule of transposition. I've given it my personal name. According to this order, if I get an equation that involves roots and powers, I'm going to try to get rid of the roots or the powers. Then I'm going to try to get rid of the division. Then I'm going to try to get rid of the addition or subtraction. Then get rid of the product. And then again, if my subject is connected to a root or to a power, I'm going to get rid of the root and the power. And so this maybe sounds a little bit more complicated, a little bit more new, first time hearing this. Let me show you how it works. So when I get an equation, the first thing I want to do is that I want to try to figure out what exactly am I trying to get for my subject. And it's clear here that you're looking for T to be your subject. So therefore, since T is my subject, I need to find out what are the other terms that are connected to this intended subject here. And you can see here that I have a W that I need to get rid of from beside the T, and I also have to get rid of this -3 here. So the question begs, who do you get rid of first? Who do you remove first? Do I remove the W, then remove the -3? Or do I remove the -3 and then remove the W? Again, you can see that W is a lot closer in proximity to T than -3. So that suggests to me that I'm going to then get rid of the -3 first. And you can see here that I'm getting rid of subtraction or addition before I get rid of a product. So it's here, subtraction here, then product here. So to do this then, I'm going to go ahead then and I am going to say here, subtract. I'm going to be adding 3 to both sides of the equation. So I'm going to end up with WT is equal to X, and carried the -3 over, it becomes +3. And so therefore then, I can now split the product of WT here. I'm looking for T. So I'm going to divide both sides by W. And that's going to be X plus 3 over W. Therefore, by simple basic cancellation, W cancel W. Therefore, T is equal to X plus 3 over W. Very simple. Now, let's look at example number 2 here. We have V take away XY is equal to 5, and I'm looking for Y. So there's a couple of things that you can actually do here. Okay, let us go with our first instinct. The first instinct here, based on what you've just learned, is to get rid of the V, then get rid of the negative X. So I'm going to go ahead then, and I'm going to do just that. I'm going to bring this V over here, and I'm going to end up with negative XY is equal to 5. Remember that this is positive V, it becomes minus V. And then since now I'm going to go ahead then and look for Y, I'm going to have to remove the negative X. So that's negative XY divided by what I don't want, which is negative X, is therefore equal to 5, pardon me, whoops, 5 minus V divided by minus X. So easily then you'll see that minus X cancels minus X, therefore I'm left with Y. But that is equal to, we spoke about this earlier, that when you're dividing by a negative number or a negative variable, we're going to just turn these around. So that's going to be that Y is equal to V take away 5 or divided by X. Easily. Now, let's make a note of this answer that we got here. And look how hard we had to work to get that answer. Let's make a note of it here. It is V take away 5 divided by X, and that's equal to, say here, Y. For me personally, if I'm going to be doing this, I'm going to immediately recognize that my subject here is negative. So I'm not going to be tempted to move that V to the right side. I'm going to just swap the position of the negative XY with the 5. So I'm going to therefore just say V. I'm going to bring over this positive 5 is going to become negative 5. And then I'm going to bring over my negative XY is going to become XY. And then bear in mind that I'm looking for Y. I'm going to therefore go ahead and divide the left side here by X, because I do not want that X to be beside my Y, and divide XY by also here X. So therefore easily then I end up with the quickest answer. X cancel X, therefore Y is equal to, oh, I'm going to have it written on the left side instead. On the right side instead, I'm going to have V take away 5 all divided by X is equal to Y. And you'll see here clearly that I get both answers. Let me know in the comments and put a timestamp beside here. And let me know which method would you use to get this very same answer. Would you use method 2 that I just did, which is my personal preference? Or do you use method 1, having to remember to turn these terms around? I'm going to go for my method always. Alright guys, so we are really in depth into all of this then. Let's look at this example here. S equal Vx plus 4, and we're looking for X. So just to summarize all of what we've done here, this is very simple here. We're going to have to bring over the 4 to this side of the equation. So we end up with S take away 4 is equal to Vx. So what this means then is that I'm going to divide both sides by what I don't want, which in this case is going to be V. And I'm going to go ahead then and divide S minus 4 over V. So then easily I'm going to go ahead and cancel this V here with this V here. Therefore I end up with S take away 4 all over V is equal to X. And X is now isolated. Or I could just say that X is equal to S over V minus 4 over V. Could write it like that if you want. Just being a little showboat there. But I would just settle with S minus 4. S, make sure it's S minus 4 over V is equal to X. So you can see that if you've ever been struggling with transposition, or you are currently being troubled by transposition, it is these very little simple tools here that I'm now showing you in this video that is literally going to change the game of transposition for you. Alright guys, and just to bring us to the end of this video, we're going to be looking at these final 3 examples here. And these 3 examples is just basically a combination of not only the first and the second rule that we learned, but we're going to be adding also that division aspect of it. So here we're looking at X take away UT, and we're going to try to do it correct the first time without trying any other methods. We're going to try to be perfect. So X take away UT all divided by 2 equals R, and we're looking to make U the subject. So the very first thing that you want to get rid of here is in fact 2. So I can either choose to cross multiply by putting the R over 1 and cross multiplying, which I don't want you to do. I would prefer if you simply multiply both sides by 2. So we end up with 2, alright, multiplied by X take away UT all over 2, and that's going to be equal to then R multiplied by 2. So this easily now allows me to cancel this 2 with this 2, so I'm therefore then left with, say here, x take away ut equals 2r or r2. Again, now I'm looking for u, so I'm keeping my eyes on the prize. U is negative, so right away I know that I'm not going to carry over that x. I'm going to carry over my ut to this side and bring over the 2r to that side because I want to keep my subject positive. So I'm going to end up with x take away 2r, and that's going to be equal to positive ut. Makes it way easier for me. So therefore then I'm looking for u once again. All the time that I'm making a new step, a new line, I'm going to always remind myself I'm solving for u. So I'm still focusing on getting rid of that t. So I'm going to have x take away 2r all divided by, of course, t. And that's going to be equal to ut divided by, say here, t, because I'm looking for u. So nicely now that t cancels t, and I'm now left easily here with the fact that x minus 2r all over t is therefore then equal now to u. And that is how you transpose that multi-step equation. So that is it, guys. Let's just put a nice red square around this final answer here. Beautiful. Let's go down to this second question here. Now we're looking here easily now at t plus 2r all over v is equal to 10, and then we're looking for r. So it's kind of the same thing. Here we're going to be multiplying both sides by v. We're going to have v multiplied by t plus 2r all over v, and that's going to be equal to 10 multiplied by v. V cancel v, so we're left with t plus 2r equals 10v. In this example now, you'll realize that my subject is already positive. So I'm just going to keep my focus on just getting rid of what is beside my r. So I'm going to just bring over my t to this side here. I'm going to end up with 2r equals 10v minus t. Let's carry this solution over here now. We end up with then 2r divided by, of course, 2 because I'm looking for r. And that's going to be equal to 10v minus t divided by 2. Cancel the 2's. I end up with r being equal to 10v minus t divided by 2. And that there gives our final answer. You just simply have to remember, what should I get rid of first? And you have to get rid of them one by one. And for my final example here, I just wanted to add a little bit of twist here. I'm adding brackets to this equation. And so once again, I have v open bracket 2 minus t all over 4 is equal to x. I'm looking for t. And so my subject is inside a bracket. So if my subject is inside the bracket, I have to therefore go inside that bracket and take my subject out. So I'm going to end up with just using v to multiply the 2, and I'm going to end up with 2v. And I'm going to go v multiplied by t, I'm going to end up with minus vt. And then all of that then will be divided by 4, and it is still equal to x. So it's equal to x then. Let us continue. We're going to then get rid of the 2. Or this should not be 2, this should actually be 4, guys. I'm going to therefore go ahead then and multiply both sides by 4. So I'm going to have 2v, whoops, pardon me. I'm going to have 4 multiplied by 2v, take away vt, all over 4. So I'm multiplying all of this term here by 4. And I'm also going to have to multiply this side here also by 4. So then this 4 cancels this 4, and therefore left with 2v minus vt equals x plus, pardon me, x times 4 is 4x. Again, keep your eyes on the prize. The subject here is t. You can see that a negative is not just in front of the v, but it also is in front of the t because vt is tied by a product. So the v goes for the negative goes for the v and the t as well. So this case here, I'm not going to be tempted, I'm going to be focused. I'm going to remove my subject on that side here. So I'm going to end up with then 2v, which is already not touched. Okay, I'm going to just bring this 4x over here. So positive 4x becomes negative 4x, and that's going to be equal to positive v. Again, my subject is t, so I'm going to have 2v minus 4x over v, and that's equal to vt also over v. And just to wrap this up now, guys, very simple enough here, that v cancels v, so I end up with 2v minus 4x all over v is equal to t. And that is it, guys. That is how you transpose any equation involving addition, subtraction, multiplication, and or division. Now, I've been with you here, guys, for a little bit over an hour. So I do hope that this particular tutorial, the time that you took out to watch this tutorial video, was able to give you clarity, make a lot of things clear, make a lot of things make sense. Many things that you've seen or currently seeing in your math classes upon watching this video is making a lot more sense to you, and so therefore you can use these tools to do other questions more effectively and more consistently. Coming up next under the topic of transposition will be transposition involving factorization, roots, and powers. So in a couple of days, that video will be uploaded, as well as coming up next also we're going to be looking at factorization, solving a quadratic equation using the factoring method. So do check the playlist below for those videos. I will link them, pin one in the comments and one in the description, as well as you may see suggestions popping up on the screen in the top right hand corner there. So until next time, guys, take care. My name is Akin. Do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions, guys, and comments down below. Hit the like button before you leave, and do not forget to share this out to your math community. Help those as you help yourself. So until next time, take care. Bye bye.